Welcome everybody to Mr. Lakatos Teaches Science. One thing before we get started with today's lesson, I want to give a shout out to all the students at IS61 who after 3 weeks of no school are doing wonderful in their effort to try to continue their learning. So what we want to work on, what you got there, Beaker?
Stuff.
Oh, wow, look at that stuff. What are we going to use it for, do you know? No? Well, let us see what we got. We got a battery with wires, some wires and light bulbs. So today's topic that we're going to learn about is electric circuits. So what is an electric circuit? An electric circuit is the path that electricity follows to make things work. So for everybody, just so you know, the electric circuit is a path for electricity to follow. Okay, the first type of circuit that we're going to talk about is called a series circuit. So, series, as in a World Series circuit. Now, what is a series circuit? Assistant Beaker, can you come and help me? Okay, so Beaker, the first thing I need is power. So I need batteries. Do you have that? Thank you. So in every circuit, you have to start with a source of energy. The first thing we're going to be using are batteries. That's what we're going to be using for our power. Now, another thing in almost all circuits is they have a switch. You see a switch in there, Beaker?
Here.
Oh, thank you. Perfect. So we have to switch, and we'll hook up the switch to our electric circuit. If I had better eyes, this would go a lot easier. Okay. But there we go. Now the next thing we need in a circuit is we need something to show it's working. So we'll use a light bulb. You have a light bulb?
Yeah.
Oh, thank you, Beaker. Oh, we have 2 light bulbs?
Yeah.
Okay, we'll hook them all together. So first, let me put in the first one. Whoops. Okay, there we go. And then we'll take the other one. Whoops. There we go. And what we'll do is we'll connect the other end to the other wire coming out of the battery. So there we go. Now, in this series circuit, electricity only has one path to follow. It can go from the wire to the switch, from the switch to the light bulb, to the other light bulb, and back to the battery. So let's see if this works. Hit the button, and you could barely see it, but if you look closely, you'll see that the lights are lit. So this is what they call a series circuit.
Any other way to hook up the light?
Well, besides the series circuit, almost all of our electricity in our houses are hooked up a different way. So how they're hooked up, it is called a parallel circuit. So in a parallel circuit, the electricity has more than one path to follow. It could go in all different directions and hook up to all different things. Okay, so this is a model of a parallel circuit. And the electricity comes out of the battery the same way to the switch. And then from the switch, it goes to the light bulb. But what happens is the electricity can either go to this light bulb or it could go around to another light bulb. So even if this light bulb did not work, okay, the other light bulb would still work. That way, when you turn off the lights in one room in your house, they would still stay on in the other room in your house.
How does the switch work?
That's a very good question, Beaker. So a switch allows us to turn on and turn off electricity. Remember, electricity has to travel through a circuit, which is a path for electricity to follow. So if there's no path, the electricity can't go. So if you look at this setup, you have the electricity going from the battery to the nail, and then here's another nail, and it goes to the light bulb and everything. Okay, so the light bulb does not light. Now, to connect these two, do you think a wooden popsicle stick will work? Let's see. You hold a popsicle stick. Oh, the light does not light up.
Maybe
I wonder
something
what
metal.
Oh, maybe something metal? That's good thinking. Let's see what we got. We have, oh, here's a paper clip. Paper clips are metal. Wonder if the paper clip will work. Let's see. You put on the paper clip. It's not working. But it should. Here, let's see. I have another paper clip. Let me try this one. Oh, this paper clip works.
I think that one doesn't work
Yeah.
because it has a cover on it.
Ooh, what? This one has a cover on it?
Yeah, because it's a color.
Oh, that's good thinking, Beaker. So what happens is, this paper clip is just like a regular wire. The paper clip has the plastic cover over it, just like a wire does. Electricity cannot travel through plastic. Plastic is an insulator. Wires, they have the plastic coating because the insulator, that way we don't get electrocuted. Okay? But metal is a conductor. Metal, electricity can easily pass through metal. So when you use metal, only joking, it's only a battery. The metal allows the electricity to pass through and light it up. So when you have the metal connecting these two, it is called a closed circuit because the electricity can travel from one side of the battery all the way through to the other side. And Beaker, when we have nothing connecting it, this they call an open circuit, okay? So when the circuit is open, the electricity cannot travel through. Okay, you got it? So, to review what we did today. Electric circuits, the paths for electricity to follow. A series circuit, electricity only has one path to follow. Something like a flashlight is a series circuit, there's just one path. Most of the electricity we use is in parallel circuits. Electricity has more than one path to follow. That way, if you turn off one light, other stuff will still work. So that is our lesson today on electric circuits. Do you have any more questions, Beaker? You good?
Yeah.
Alrighty, and we'll see you again when we visit magnets. Have a good day, everybody.